All right, now for the fun story problems that you all love so much. These are the problems that I skipped in 8.1 because, again, 8.1 has you doing them using the old way, and there's nothing wrong with it, but some of these pictures get to be absolutely brutal, and using component form and vectors makes the problem 1,000 times easier. You write your two vectors, you add them together, and then you find the magnitude and the direction angle, and you're done. You don't have to have a perfect picture. You don't have to analyze a whole bunch of things. Law of cosines itself takes a lot of work. These are a lot more streamlined, and you appreciate it a lot more versus doing the other way. If we weren't doing this distance learning, I would have had you do the other stuff because it's good practice, but most people end up pulling their hair out trying to do law of sines and law of cosines on a number of those problems. So back from 8.1, these are your component vectors, these are your resultant vector, okay? And a lot of the pictures I had you draw, I said just draw a rough sketch. It's just important to be able to just draw a quick rough sketch of what those vectors are gonna look like, okay? So example 8 is the first one I have. It's on page 496 if you want to read along. A quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40 degrees. So I drew a vector first. This is him running, okay? He's going 5 meters per second. Then he throws the football at a velocity of 25 meters per second. That's the magnitude of this vector, with it at an angle of 40 degrees with the horizontal, okay? What is the resultant speed and direction of the pass? So this would be my resultant vector. You would have to go through, find these angles. This is a 40-degree angle, so this would be a 140-degree angle. Then you could go through and you could do law of sines, law of cosines. You could actually get away with law of sines on this one. But we're going to do it using vectors. So you take your first component vector. I need my direction and I need my magnitude. So my direction is 0. Okay? If I drew an x and y axis here, my direction is 0. So I have 5 cosine of 0, and then 5 sine of 0. They gave me my magnitude and direction, so this vector is 25 cosine of 40 and 25 sine of 40. To find my resultant vector, I literally just add them. Now, this is where you're going to want to utilize your calculator. These are not going to be nice numbers, and you don't want to round until you get done, okay? So, to find my x component, I'm going to take 5 cosine of 0, make sure you close that parenthesis, plus 25 cosine of 40. So this is about 24.151. I am going to save this. I'm going to save this in my calculator as A. And we've done this, did this a while ago, okay? Down here you have the store button. So right above your on key you have the store button. I'm going to store this as A. So I'm going to hit alpha A. And then to find my y component, I do 5 sine of 0, make sure you close that, plus 25 sine of 40. And so this is approximately 16.070. And I'm gonna round this, I'm gonna store this as B. So I'm gonna go down here to my store button and store this as B. So there is my resultant vector. I need to know the speed, which is my magnitude, and the direction of that vector, okay? So my magnitude, if you remember, because this is in component form, is the square root of a squared plus b squared, okay? And so I have the a and the b on my calculator, and so I can type in and I can do the square root of a squared plus b squared. And so the pass of the football was thrown at 29.0 and meters per second. Then we need the direction angle. So just like we were doing on the previous example, my direction angle is going to be the inverse tangent of, and in this case this is stored as b over a. These are both positive, so it's in quadrant 1 essentially if you're thinking in terms of quadrants. So we don't have to do anything special to it. So inverse tangent of b over a. And so my direction angle is 33.6 degrees. So the next one I'm going to do is the guided practice at the bottom of page 496. Okay. So this one says, what would the resultant velocity of the football be if the quarterback made the same pass running 5 meters per second backwards? Okay. So the only difference in my picture, and they didn't give you a picture for this one, but the only difference in my picture is now this vector, he's running backwards, and then he throws the pass at 25 meters per second with a direction angle of 40 degrees, okay? So what is his resultant? So again, tip to tail, if I'm doing this to scale, this one would probably be a whole lot shorter. But there's gonna be my resultant vector, okay? Something to that effect. But we just need to do the same thing. We need to take this one, my magnitude is 5. The difference between this one and this one is my direction angle. This, my direction angle is 0. This one, my direction angle, if I put this again on an XY axis, is 180 degrees. So I have the cosine of 180 and then 5 times the sine of 180. This vector is still the same. This is going to be 25 cosine of 40, 25 sine of 40. So to find my resultant vector, I add them together. So I have 5 cosine of 180, close that parenthesis, plus 25 cosine of 40. And so this is approximately 14.151. And then I take 5 sine of 180 plus 25 sine of 40. And I get 16.070. So again, this is going to be a quadrant 1 vector, and we're thinking in terms of quadrants. So, and I should have, and I didn't, but I'm going to store this one as B. And then I'm going to go back and, oh, come on. There we go. 5 cosine of 180, 25 cosine of 40, and I store that one as A. So to find my magnitude, to find the speed of his pass, I take the square root of A squared plus B squared. So 21.4 meters per second. And then the angle of his pass, I do the inverse tangent of B over A. Again, this is positive. so I'm not going to have to do anything to it. And so the angle is 48.6 degrees. All right, I'm going to do one more. And there's no, you don't have this problem anywhere, but I wanted to do at least one more. So you'll have to just listen. A soccer player running forward at 7 meters per second. So I have a soccer player running forward at 7 meters per second. Kicks a soccer ball with a velocity of 30 meters per second at an angle of 10 degrees with the horizontal. So this one is 30 meters per second at an angle of 10 degrees. So my resultant velocity, or my resultant vector is going to look something like this. Okay, so what is the resultant speed and direction of the kick? So this vector is 7 cosine 0, 7 sine of 0. This one is 30 cosine 10, 30 sine of 10. This angle is always with the horizontal. So in some of the problems, they might give you a bearing, so you have to go back and you have to find this angle from the horizontal, okay? So we add those two together. And I'm not gonna forget to store it as A and B this time. So 7 cosine 0 plus 30 cosine 10. So this is 36.544, store as A, and then 7 sine of 0 plus 30 sine of 10, and this is 5.209, and I'm going to store that as B. So then to find my resultant velocity, again, I take the square root of A squared plus B squared. And I get 36.9 meters per second for my units. And then again, these are both positive. So inverse tangent of B over A is 8.1 degrees. There you go.